Okay, so today's I'm gonna be solving a number of visible people in a queue. So I haven't solved this problem before, and I opened the problem and read it like yesterday and tried to record the solution, but was not able to come up with a good one within like hour maybe. So today I'll try to do a second round and see if it's gonna be successful. So the problem is that there is a line of people or like of minions like that, and they can see the next person standing if if the height is high enough, and like I can just draw a parallel line and see that, let's say, this person can see this one. As I draw a parallel line, it doesn't hit any other one, and this person also can see this one, but this person cannot see this one because this person is standing behind this one. But this person can see this one also, so basically number of people that this person can see is 3. Number of people that this person can see is 1. Number of people that this person can see is 1. This number of people that this person can see is 1. And this one can see 1, and this one can see 0. Actually, this person can see 2. Yeah, this person can see this one and this one. So if I have an intuition that this problem should be solved with monotonic stack. So I will try to show it now. So I'll be storing number of people the person can see as the increments, and every time I update the stack, I'll record the number of every time I update the stack in front of this of the person. I will kind of record +1 element this person can see. So basically, initially I have this 10, so I push it to the stack, then I add 6. 6 is pushed in front of 10, so I update 10 +1. Then I check 8. 8 is checked before 6, so I record +1, and then 6 is removed because 8 is greater than 6. So I record again 10 +1, as now 8 is in front of 10. Then I pushed 5 and update 8, gonna be +1. Then I pushed 11, and then 11 is greater than 5. So first it was recorded +1, and then 5 is popped, and then again 8 updated to +1, and then 8 is popped, and then 11 is in front of 10, so +1, and 10 is popped. So now I have stack of just 11, and then I pushed 9 in front of 11, so I update 11 plus, so 11 gonna be also +1, and that 11, and that's gonna be end of operation. And now I count the increments. So for the 9 I have none, so 0. For the 11, 1. For 5, 1. For 8, 2. For 6, 1. For 10, 3. And this is exactly the array that I should be outputting. So 3, 1, 2, 1, 1, 0. And let's try the next example. 5, 1, 2, 3, 10. So I'll be pushing the stack. So 5 initially, then 1 gonna be checked against 5 +1, and I pushed the stack, and then 2 gonna be checked in front of 1, so update 1, 2, and because 2 is greater than 1, I update the stack, and then I update 5 +1, and then I check 3. 3 is pushed, checked before 2, so I update 2, and then 2 is pushed out of stack, and then update 5 plus 1. This is stack, and then I check 10. 10 checked against 3, so plus 1, and then a 3 is popped. So we have 10, and 10 is checked against 5, so plus 1 here. So 4 here. So 5 is popped, and then I have stack 10, and then this is the terminal state. So I calculate once, it's 4, 1, 1, 1, and 0, and this is exactly the answer. Yeah. So looking at this one, so the 2 stays in front, like for the 1, the answer is 1, because 2 stays in front of like 1 before, like say 3 and 10, and it's like blocks the view for the next higher elements. So this is gonna be my approach to this problem, and I'll try to program it. So I'll have int n equals heights length, and then 4, and then I'll have the result int res equals new int n, and then stack integer where I'm gonna store just the indexes, stack equals new stack, and then 4 int I equals 0 other than n I plus plus, and then here I'll check if stack so while stack is while it's not empty, and stack peak is less than heights and I. Stack peak heights, because I'm gonna store the indexes. I'm gonna int index equal stack top, and then res index plus plus, and then res if stack is empty, not empty, is empty false, then res stack pick plus plus, and then stack push I, and then return res. So this one, so initially I check like every time I pop the element from a stack, I increment the delta, and then I increment the delta the res also when I'm gonna about to push into stack in front of the element, and this is gonna be it. So let me quickly trace if this program works for the input arrays. So I have 10, 6, let me just record it here. So we have 10, 6, 8. No. No. Okay, so this is incoming numbers. So I is equal 0, stack is equal stack not stack is empty here, stack is empty again here. So and then res. Res initially is gonna be, let's say I'm gonna so input and then res 0, 0, 0. So initially I is 0, and then stack is empty, and then I'll push the I to the stack, so stack becomes equal 0. So I push the element to the stack. The top element is index is 0 now, so I moves to 1. So stack is not empty, and the height of the top element of the stack is actually greater so I'm thinking if this is gonna be equal, what it should be if they're gonna be equal. Can the person can see the other one? Yeah, I should. No, it cannot see. That's why I need to push keys like the current height is equal to the height of the previous one element I need to push, so I don't need to pop. Okay, this one is correct. So I is equal 1 as in this case height 6 is less than 10, and then I jump over this one, so I go stack is not empty, so I increment the top from the stack, so this becomes 1, and I push the stack becomes 0, 1, and then I is equal to, so 8, I check, okay, stack is not empty, and height of current element of head of the stack is less than current element, so 6 is less than 8, so I do pop and increment the index of 1, so I increment 1, and then I push, I check also the top, go out of the stacks, so because like the next one is 10 is not less than 8, so I go out of this while loop, I go to the next, this check stack is not empty, so I update the head of the stack, so this one becomes 2, and I push element to the stack, so it was 0, 2 now, so I moves to 3, stack becomes, so I moves to 3, this is 5, 5, we check 5, is it if it's greater, greater than 8, no, so I exit this loop, and I update the current head of the stack, so the current head of the stack is 8, so I update delta, and I push the index of 5 to the stack, and then I check for the 4, and then 11, so 11 is greater than 5, So I pop index of 5, and before doing that update the result for the 5, and then stack becomes like this one. Stack was on the start of the iteration, stack was like this, then I pop the element, then I check again if 11 is greater than 8, yes, then I update the 8, and then I pop it, and then again I check if 11 is greater than 10, yes, I update it and I pop it, and then stack is empty, I don't need to update it, and then I push the 11 index to the stack, so it's gonna be 4. And then for the I equals 5, I check 9 is less than 11, so I don't go into this loop. I check if the stack is empty, it's not, so I check if I update the value for the res value for the for 11 for the element under index 4, so I'm going +1 here, and then I push 9 to the stack. I push like 0 of index of 9 to the stack, so stack becomes 4 and 5, and the result is gonna be 3, 1, 2, 1, 1. Okay, seems like it should be working. Yep. Not the difference. I wonder. I literally rerun it. So where is my solution? Where is their solution? I lost. So let's submit it again, because I don't understand why it is not performing that good. Again, interesting. Are they reusing this? So find the difference. Stack and hit and So they are changing. So instead of going from front to back, from left to right, they are going from right to left. Yeah, some other. And then they are doing what? They are updating. It seems like very similar solution, but for whatever reason, it gives a better distribution. So let me check the time. Okay. So what are those people? They are just not using the normal stack. They are using just integer array for the stack. And also the same trick with starting from the end. Is it something they have? Okay, they don't have editorial. Monostack. So the same, starting from the end. So they start from the end and then start from the end and then check the heights and then starting from the start. So the count, the height, the current height. Okay, so it's like iteratively, if that person sees all of them, okay, so I'm gonna call it today. So this one gonna be pass, but I'm taking like home assignment to check this solution and figure out like why it works.